In this video, we're going to continue to look at Bayes' theorem, and this time we're going to put more focus on the complements. But it's really kind of the same process as before, and using much the same information we had before. And this just gives us more experience in setting up the equations. So again, let's go back to our picture. I'm just going to use, instead of using A and B this time, I'm going to use F and E. So once again, let's say we have this set F and F complement, and we have this set E over here. Then we have E intersect F and E intersect F complement, like this. And as we know from previous videos, the probability of E then is going to be the sum of these two probabilities. Again, we can just add them because there's no overlap between them. If there was any overlap, we could not simply add them. We would have had to subtract the overlap, or that is, subtract the intersection. So we have this. And now, just as we did previously, we want to find the probability of F given E. And of course, that's always going to be the probability of the intersection of F and E divided by the probability of E. Remember, when you set up this conditional probability, it's always the intersection of these two divided by the probability of this one. And then, of course, remember from before that this, we can make this equal to the probability of F times the probability of E given F. And of course, you remember why that's, so let me just put it on the side here. Remember, because if you have the probability of E given F, that's going to be equal to the probability of E intersection F divided by the probability of F. And so if we multiply this out, we can say the probability of F is equal to probability of E given F equal probability of E intersection F. And so that's what I did here. So I replaced probability of this intersection with this times this. In the denominator, we can just use what we have up above, which is probability of E intersection F plus the probability of E intersection F complement. And finally, we can rewrite, let me rewrite the numerator first. And so, again, we can replace this with the probability of F times the probability of E given F plus the probability of F complement times the probability of E given F complement, like that. So again, notice we kind of went through the same process we did previously, get that. We just wanted in a slightly different form now so that we can use it. And let's do some examples. So say cell phones have been found to be defective and it's found that 35% of the defective phones have a scratch on the case. So again, defective means the phone isn't working, and then 35% of defective phones have a scratch on the case. 2% of the good phones case, and a total 5% of the phones are defective. And find the following probabilities. Probability that the phone has a scratch, the phone is defective given that it has a scratch, the phone is not defective given that it has a scratch, and finally, I want to know the probability the phone is not defective given that it does not have a scratch. So let's take a look at this problem. First, let's set up, usually the best thing to do is set up some definitions as to what's what. Let's call for a solution, let's say SC means scratch, has a scratch. G is not defective or good. And D means defective. And let's sort of organize and see what information that we know based on what we're given. So let's look at what's given up here. First of all, we can actually maybe jump down to this last part here. It says we know 5% of the phones are defective, so we can write that down. So that's 0.05 are defective. And so we know, therefore, the rest have to be good. So probability of the phones being good are 0.95. And let's see, what are we giving up here? 35% of the defective phones have a scratch. So let's think a minute, what does this mean? The probability that they have a scratch, given that they're defective, is going to be 0.35. In other words, we're looking at the group of defective phones, and of that group of defective phones, 35% have a scratch. So given it's defective, probably it's 0.35 that has a scratch. And now what does this mean then? How about if the rest of the phones, the rest of the defective phones don't have a scratch? And that has to be 0.65%, doesn't it? Or excuse me, 0.65 probability. Because if of the defective phones, 35% have a scratch, that means 65 don't have a scratch. And we can write don't have a scratch as scratch complement. And then also we're told that 2% of the good phones have a scratch. So given that the phones are good, 2% of those have a scratch. And so that means given the phones are good, 98% don't have a scratch. So I think that's all the information we have at the moment. So now we want to find the probability that the phone has a scratch. Part A, probability that has a scratch. Is going to be the probability of the scratch intersect with the good phones plus probability of the scratch intersect with the defective phones. That would cover all the possible phones with scratches. And now, of course, remember this can be written as this times the probability of it being good. So let's write that down. Probability scratch, given it's good, times the probability of it being good. Over here, this is probably scratch given that it's defective times the probability that is defective. And so this is going to be 0.02. This is going to be 0.95. This is going to be 0.35. This is going to be 0.05, like this. And if you put that in your calculator, you will get 0.0365. Now for part B, the phone is defective given that it has a scratch. Probably defective given that it has a scratch. That can be written as probability defective intersect scratch times the probability, that's all. And then in the denominator, we're going to have probability of scratch. I shouldn't have made this line so long, otherwise I could have fit it in up here. So again, remember in the numerator, this can be written as probability of scratch given it's defective times probability of defective. And probability of scratch, we can get that from part A. We already calculated that. And so this is going to be 0.35 times 0.05. Probability of scratch was up here, 0.0365, like that. And put that in your calculator, we get 0.479. So for part C, the phone is not defective given that it has a scratch. So let's take a look at that. So it has a scratch, and given it's not defective, which we call it good. Once again, this is going to be probably good intersect scratch divided by the probability that it has a scratch, which we've already calculated. And in the numerator, again, remember, I should mention before, remember, we're always picking something we can use here. Like, so here, you could write this as probability scratch given it's good, or you can write it as good given it has a scratch, but that's actually what we want to find. And also, we want to use what we know. We know this, so that's the version that we want to use. So let's do probability scratch given that it's good, times the probability it's good over probability scratch. And let's plug our numbers in. Again, the denominator we found in part A already, so we can actually write that down. And the numerator is 0.02 times 0.95. And I'm going to put my calculator, get like 0.5205 or 0.521.